All right, hello everyone. This is Rebecca, and today I'll be going over the CS88 Fall 2021 Final Problem 10 Mario Cards. Let's jump right into it. So, the problem says, friends from the world of Mario Kart have gathered to play some cards. The players table contains information about the player ID, player name, and the number of card games that player has won in the past. The cards table contains information about each playing card, including the suit of the card, either club, diamond, heart, or spade, the card value, a number from 1 to 13, and the player ID of the player that holds that card, or -1 if no player has that card in their hand right now. Okay, so just to recap from that paragraph, we have two tables, the players table and the cards table. The players table has 3 columns, the player ID, the player's name, and how many games they've won. And then the cards table has the suit, value, and dealt to columns. What I usually like to do when thinking about SQL problems is I kind of draw arrows to columns that are related to each other. So for example, in this case, the ID column of the players table is related to the dealt to card of, the dealt to column of the cards table, because the dealt to column contains the player ID who is currently holding that card. So for example, if we're looking at the first row, the 5 of clubs is dealt to the player with an ID of 4, which happens to be Luigi, right? Another thing to note about the table is that notice that the dealt to column, the values are, it is possible for them to be -1. And remember from the problem statement that it means that there is no player who has that particular card. This will come in handy in part A. Okay, cool. So looking at part A, it says find the card suit and card value for all cards that have not been dealt to any player. Okay, so usually when I'm approaching any SQL problem, I kind of have like a 3-step approach, which is first we want to check what table we want to select from. The second step is we want to check what information we want to display and what information we'll need in order to display the information that we want. In other words, like what columns will we need? And then the third step is to kind of determine what conditions that need to be true in order for us to like kind of filter out some of the table rows that we don't need. So conditions. You might also notice that these 3 steps are kind of associated with particular clauses in a SQL select statement. So for example, the table step is associated with like the from clause, because we select from a given table. The column step is associated with the select part. And then the conditions can be something like where, sometimes also group by or having. Okay, cool. So let's now start writing code for part A, right? We know that we want to select something. We'll think about that later, but first let's determine what table or tables we need to select from. So we know that we want to return, we want to display rather the suit and the value of a particular card. If we look back up at the tables that we have, only the card table has suit and value as columns that we can select from. We also want to only display the suit and value for cards that have not been dealt to any player. And the cool thing about this is that we can determine if a card has been dealt or not by looking at the dealt to column, right? If the value is -1, that means that the card has not been dealt to any player. And so all of the columns that we need are in the cards table. So we can say we want to select from cards. Now let's think about what exactly we want to select. Well, in the output example, we can see that there's a suit column and a value column. So we can select suit and value from the cards table. Okay. Next, we want to look at the conditions, right? So which suits and which values do we want to display? Well, we only want to display the cards that have not been dealt. How do we know if a card hasn't been dealt? We check the dealt to column and we see whether it is equal to -1 or not, right? So in this case, we want the rows that are equal to -1, right? Because we want the cards that haven't been dealt. So dealt 2 is equal to -1. And we can end our select statement there. Okay, cool. Moving on to part B. Okay, so part B says you're trying to find players who have similar playing levels to other players. Find all unique pairs of player names where both players in the pair have won the same number of games. The player names within each pair can appear in any order in the resulting table. Okay, so again, let's go through the 3-step process, right? We're looking at the tables, the columns that we need, and the conditions. Okay, so we want to select from or select something from a certain table. So what tables do we need? Well, we know from the output example that we need to output the names of players. So we know for sure that we're going to need the players table at some point, right? But we also need the cards table. Or sorry, we don't actually need the cards table. That was my bad. I'm getting ahead of myself. I'm thinking of another problem. But so what we actually need is, since we're displaying the player pair, so 2 different player names, we can't just select from players by itself. We have to select from a join of players with itself. So we could write, or we might think that we would write from players, comma players, but this wouldn't really fly in SQL syntax because the table name names are the same, so it's kind of ambiguous. Instead, what we want to do is create an alias for each of the tables, right? So what we want to do is we select from players as A, for example. Sorry, do this as A, and players as B. Once again, because we have pairs of players, not just single players themselves. Okay, cool. Next, let's think about the columns that we are displaying in the result. We can see from the example output that we have the names of the 2 players in each pair. So what we can do is we can simply say a.name, so the name from the first table and the name from the second table. Okay, cool. So now what we need to determine is the conditions. Which names do we want to display? Well, if we look back at the problem statement, it says find all unique pairs of player names where both players in the pair have won the same number of games. So the unique pairs of player names is kind of a little bit hard to think about. So let's first think about the most straightforward condition, which is that the pair has won the same number of games. If we look back at the players table, we can see that there is a very useful games won column that tells you the number of games won by that particular player. So what we can do is we can check if one player's games won value is equal to the other player's games won value. So we would do that by saying a.games won is equal to b.games won. Okay, cool. And now what we need to do is we need to ensure that we're finding the unique pairs of player names. So obviously, when we're joining the 2 tables together, we might have a row where it's something like Peach and Peach are the 2 names of the players, right? And obviously Peach and herself will have the same number of games won, but we don't want to display that row, right? Because that's kind of obvious and meaningless, right? We want to have 2 different people, right? So that's one thing we have to watch out for. The other thing we have to watch out for is if, for example, let's say we're looking at Luigi and Peach, right? They both have the same number of games won, And when we're doing the table join, which I will screen share later to visualize that if you're having trouble, but both Peach and Luigi have the same number of games won, right? So when we're doing the table join, there will be a row in the table that's something like Peach, Luigi, Luigi, Peach. But we only want to display one of these rows, not both of them, right? Because this pairing is basically the same, right? It's one Luigi and one Peach. We only want to display one of these rows and not two of them. So how can we do that in SQL? Well, what we can do is we can compare the name of the player in table A and the name of the player in table B. More specifically, what we can do is can say where they have the same number of games won and A dot name is less than B dot name. And we can end our select statement there. And the reason why this works, right, is because if A dot name and B dot name are the same, right, this condition would be false. So we don't return the row in which, for example, we have Peach and Peach, right, because they have the same name. Similarly, if we have like a duplicate pairing, like Peach, Luigi, Luigi, Peach, it would only return Luigi, Peach, because when we're comparing two strings in SQL, Luigi is indeed less than Peach because alphabetically L comes before P. Okay, and so that's how we kind of get rid of this duplicate pairing. Okay, so before I move on to part C, I thought it would be useful to have kind of like a visualization of what is happening behind the scenes. So I'm going to use my laptop to screen share code.cs61a, which is basically 61a's online code editor, which I believe is publicly available. So if you're a CS88 student and you want to try some like things out on SQL or Python or Scheme, or sorry, Scheme is not actually covered. So Python or SQL, then this is actually a really good resource. So here I have some pre-written code that I'm just going to copy and paste that will create the players and cards tables. You guys don't have to worry about this. I'm just creating the tables because they're not already there for me. And then just to prove to you that the tables have been created, let's try selecting everything from players. And you can see that this is exactly the same table that we see on the exam itself. And then select everything from cards. And we can also see that this is, again, the exact same data. So let's copy and paste the solution for part B and kind of see what is happening here. Okay, so if we go step by step, right, we can see that we have the two players tables, which we call A and B, and then we join them together. So then for each row in A, right, we kind of merge it with the rows in B. And you can kind of see this visually with the coloring of the rows as well. And then next, we kind of combine the two tables, and then this is where the where comes into play. So remember from the where clause here that we're checking that the number of games won by the two players is equal and the names are different, and the first name is alphabetically before the second name. And so you can see that the rows that are highlighted in green are the ones that we keep after we filter everything else out. So for example, here we can see Mario and Toad, they indeed have the same number of games won, 3 and 3, and Mario is indeed less than Toad, the string, because M comes before T. And then the same thing with Bowser and Peach, who have both won 4 games, and so on and so forth, right? And you can see here that from the example that I was giving earlier, we have the Luigi-Peach pair. Next, what SQL will do is that it'll eliminate all the rows we don't need. And then finally, we get rid of the columns we don't need, right? Because remember, we're only selecting the names of the two players. And so this is our final result. Okay, I'm gonna screen share back on the iPad now. Just a second. Okay, cool. So moving on to part C now. Part C says, for each player that has at least one card, find the total card value for all the cards that they currently hold. Okay, once again, let's think about our three-step process of looking at which tables we need, the columns that we're displaying, and then finally, any like filtering conditions. Okay, so we know that we're going to select something, which we'll figure out later, and then we want to determine what table we need. Okay, so looking at the example output, we can see that we want to display the name and total value. So name, we know that we can get from the players table. So we know that we're going to need the players table. And then the value of the card, if we look back at the problem statement here, the value of a given card is located within the cards table. And so that means we'll need both the players table and the cards table. You might be wondering, like, can I do something like from players as P, cards as C? This is also completely valid as long as you use the aliases and whatnot. But since these two table names are completely different and ambiguous, we don't really need to have the aliases like we did in part B. So I'm just going to keep it as from players, comma cards. And then let's look at the columns that we want to output, right? So if we look here, we want to output the name of the player, right? So I can just go ahead and put name here. And then this other one is kind of different from the other columns that we've had before, where we're displaying the total value of all of the cards that that player has. So how might we calculate the total value? Well, we want to add up the value of all of the cards that that player has, right? So is there like a SQL function that we can use for this? If you're thinking of sum, you're definitely on the right track. So indeed, we want to use sum, right? And we want to sum all of the values in value, aka the value of the card, right? And that's the number that we want to display for a particular player. So for example, Peach has a total of 11. Okay, cool. So we've determined the tables and the columns. Now we want to look at the conditions. So we want to make sure that we're associating each player with their own cards, right? Because we don't want Peach's total value to include Mario's cards, right? So what we want to make sure we do when we're filtering the results is we want to make sure that the del2 player ID is equal to the player ID that's in players, right? We associate Peach with Peach's cards only. We associate Mario with Mario's cards only. And then the last thing that we want to do is we want to make sure that we are grouping by either name, ID, or del2. So in this case, I'll just say name, but either like you could also do like group by ID or del2 as well. And the reason why we do this will become more apparent when we hop over to the visualization right now. So let's go over to code.cs61a. Okay, so let me just copy and paste this part C solution. And then we can look at what is happening step by step. Okay, cool. So we can see that we have the two tables, players and cards, and then we perform the join operation on the two of them. And then what happens in the where clause, right, is, as I mentioned before, we only want to associate a given player's cards with themselves, right? So we check if the player ID matches the del2 ID, right? So you can see here that this row is green because the player ID 1 is matched with the del2 1, which means that the 11 of hearts belongs to Peach. Similarly for Mario, his player ID is 2, and then the 12 of clubs with del2 ID of 2, which is Mario. Okay, cool. Then SQL will just eliminate all the rows we don't want. And then you can see here, this is the what happens during the group by phase. So you can see that each of the groups are kind of marked by their own color. So peach is kind of like this purplish color, and then all the Mario rows are green. And the reason why we do this is so that we can use the sum function appropriately, right? When we're summing, we have to think, what are we summing? Are we summing all of the values, or are we summing the values for a particular player, right? We want to sum the values for a particular player, which is why we need to use group by. And this is also the reason why we can either group by delt2, which is the player ID, or we can group by ID, which has the same effect, or we can group by name, which is okay in this case because all of the players have unique names. So we can see here that what we want to happen is that we sum all of the values of Peach, which is just 11. We want to sum all of the values of Mario, which is 12 plus 9 plus 9. All the values of Bowser, which is 1 plus 8. And then Luigi with just 5. And you can see that that is indeed what happens. So we're breaking up the groups. And then this is our final result. Okay. I'm gonna screen share back on the iPad now. Just a second. Okay. Cool. So now that we've done part C, let's now do part D. So part D says, in this game, any player wins if they have at least one pair of cards that add up to exactly 21. Find the name of all players who win according to this rule. Okay, so once again, let's go back to our tried and true SQL problem approach. So our first step is to look at what tables we need, then what columns we want to display, and then finally, any conditions that we want to filter our results. Okay, cool. So we know we wanted to select something, which we will determine later. And then we want to select from which tables. Okay, so this one is a little bit tricky. So we know for sure that in order to display the name in our final output, we're going to need the players table, right? But we also have to look at what columns do we need in order to kind of figure out who actually has at least one pair of cards that adds up to 21. So the key here is pair of cards, right? We can't just do a select from players and cards because the cards table only lists like one card at a time. If we want a pair of cards, then we need to be able to look at cards joined with another cards table. And since we have two tables with the same name, it would be a really good idea to have an alias. So I'm going to have an alias for the players table, which is P, and then an alias for each of the card tables, which will be C1 and C2. So cards as C1 and then cards as C2. Okay, cool. So we looked at the tables that we want. Then let's think about what columns we want to display. So looking at this output, it looks like it's pretty straightforward. We just display the player name. So we can select p.name. Step 2 is done, and now we're on to the different conditions. Okay, so this is the bulk, where the bulk of the problem is, right? So let's reread the problem statement again to make sure that we understand what exactly we want to filter. So it says, the player wins if they have at least one pair of cards that add up to exactly 21. So we know that we're probably going to use the value column to figure out this, right? So specifically, how this translates to SQL would be C1.value plus C2.value is equal to 21. But we also want to make sure, right, that the player has both the card for has the pair of cards in C1 and C2. And the way that we check if the player indeed has those cards is by making sure that the ID of the player is the same as the delt2 value, right? And it has to be the same as the delt2 value for both the C1 table and the C2 table. So we can do an and here and check if ID is equal to C1.delt2 and C1.delt2 is equal to C2.delt2. And by the transitive property of equality, all of these are equal to ID. So what I mean by the transitive property, for those of you who might not be familiar, if I say something like A equals B and then B equals C, that basically implies that A equals C. So what I'm doing right here is basically I'm saying if I want to make sure that ID is equal to the delt2 value of the first card, and it's also equal to the delt2 value of the second card. Okay. Cool. And then finally, what we want to do is we want to make sure that we return only one name if they have at least one pair of cards, right? Because like, think about it. What if Mario has like, I'm not sure if this is exactly what the value is, but I'm just making up like a value here. Like what if he has a 12 of hearts and like a 9 of diamonds, right? But he also has like a 12 of diamonds and a 9 of hearts, right? That means that there's two ways for Mario to win. If we didn't have the additional group by the player's name right here, what would happen is that the resulting table would be something like Mario, because there's two ways for Mario to satisfy the winning condition, right? But we only want Mario to display once, right? Because remember, it says at least one pair of cards that add up to 21. So the way that we get around that is by doing group by p.name, because group by will kind of consolidate all of the rows in which like a particular player has a winning pair into one row. And so instead of having this name Mario, we instead consolidate that into just Mario or whoever has at least one winning pair. So once again, I'll head over to code.cs61a.org to kind of show you a visualization of this because I think it's pretty helpful. All right, so I'm just gonna copy and paste this solution to part B into the SQL interpreter. Cool, and then as you can see, it does output what we expect, which is Mario. And so let's go through this step by step. We can see the three tables that we wanted to select from, the players table, which we aliased as P, and then the two cards tables, which are aliased as C1 and C2 respectively. Then we perform the join, and it becomes a pretty big table. So we just scroll more, okay, cool. And then the join happens. And then now we're filtering based on the where condition. So remember in the where, we check that the card indeed belongs to that particular player by doing the ID checking with the delt2. Sorry, when I click, it just kind of jumps to another place, but yeah. And then the other condition here is we check that the two card values add up to 21. So if we look at the rows that are highlighted in green, for example, we have this row here. Notice that the player ID and the delt2 columns of this particular row are all 2, right? It all belongs to the same player, which is Mario. Mario has the 12 of clubs and the 9 of diamonds, right? And these two cards, their values add up to 21, which is why we want to keep this row when we're filtering out everything else. Okay, cool. And then as SQL does, it gets rid of all of the rows that we don't want based on the where clause. And then finally, we group the results by the player name, which is Mario, right? Because we don't want to have Mario, 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 Mario. We only want to have the name of his name once, because he might have multiple winning pairs, which is the case here. And so finally, we output Mario. Right. I hope that was helpful, and that's how you solve problem 10 Mario Karts.